Alright, so we're doing 3-3, which is using several transformations. So basically, we're taking what we did in 3-1, which was transforming equations with addition and subtraction, and what we did in 3-2, which was transforming equations with multiplication and division, and we're basically putting them together. So you're going to have to do multiple transformations to solve the problem. So as we mentioned in earlier sections, the goal when solving equations is to isolate the variable. Now, I might not have actually used the word isolate. Isolate means get the variable by itself. Sometimes it's solve for x, because x is a lot of times the variable. Again, these all mean the same thing. Now, to do this, we may have to do one or more transformations. Order of those transformations is very important. You have to do it in a specific order most of the time, or you'll get it wrong. So we can think of the order as reverse order of operations, okay? It's basically kind of the opposite of what we normally do, because we're solving it. So order of operations is addition and subtraction, and then it's multiplication / division, and then so on and so forth. And this might change if we got division bars or parentheses. It just depends on the circumstances. And basically, you kind of, again, you're working backwards from what you did before. So hopefully I'll give you some examples, and you'll be able to, as you keep doing more and more, you'll be able to recognize what you're supposed to do. So in this case, we have 1/2 x plus 3 equals 9. So we have to do reverse order of operations. So we're really trying to get whatever the variables with, which happens to be that multiplication, we're trying to get it by itself. So first we have to actually get rid of this this plus 3, so we have to do that -3. Okay, so therefore I have to do it on either side, so those cancel each other out, so I'm left with 1/2 x equals 6. Now this looks like one of our equations where we need to get x by itself by multiplying by the reciprocal, 2/1. Oops. Okay, so those cancel out, and we're left with x equals, and then 6 times 2, which is 12. So x equals 12. Now, you can always plug it back in to double check that it worked, right? 1/2 of 12 is 6, and 6 plus 3 is 9, so we did get that right. Okay, so again, we need to get this x by itself, and right now it's connected, it's linked to that 2x, so we have to add the 5 first. Again, like we said, we're doing reverse order of operations, so we're doing addition or subtraction first. So now we have 2x equals 16, and now we have that problem where we're just dividing 2 on both sides. So we get x equals 8. Now, we have a fraction bar. This gets a little bit more intricate, because we can't add this 5 until we split up the numerator and the denominator. Okay, they have to be separated. So we have to basically, this is linked together until we get rid of that 9. So I'm going to multiply by a 9/1, right? A 9. So really 9 on both sides. So those 9's cancel out. Oops. And we're left with w minus 5 equals 18. So we had to split up our fraction bar first, even though it was multiplication and you were thinking, oh, I need to add first. But like we said up at the top, we said sometimes it might change if we have division bars or parentheses, okay? So we have to kind of see what is connected and what we need to split up to get our variable by itself. So now we're going to add 5. So we have w equals 23. And again, you can always check back. 23 minus 5 is 18, divided by 9 is 2. So now, there's actually 2 ways to solve this problem. I'm going to show you one way, and then I'm going to show you another way. Okay? So, for the first way I'm going to distribute. Okay? So I get 4y, and then 4 times a negative 8 is negative 32, minus 7 equals, oh, that just got all warped there. That, I believe, is a 15. Oh, there we go, there. It's good. 15. Okay? So now I'm going to actually combine like terms, okay? So if they're on the same side, you're combining them. You're not again, I'm not adding 32 to both sides because I'm combining these first. So 4y equals, and well, not equals, minus 39 equals 15. So now that I have this, I can now move. I'm having some technical difficulties with this. Okay, here we go. So now I'm going to add 39 to both sides. So I get 4y equals, and that would be, that's going to be 4, carry the 1, 54. And then divide by 4. And that is not going to be a whole number, so we're going to actually rewrite it as an improper fraction, which I can divide both of them by 2. So 54 divided by 2 is 27 halves. Okay, so that's first way. I'm going to do the second way over here in red. Okay, so I'm going to rewrite the problem just so we can see it again and I can work with it. Right now, if I look at this right here is linked together, okay? Everything's kind of clumped together, so unless you distribute it, you can't separate it yet. So we're actually going to add 7 to both sides. So I'm going to move this 7 over here. So I have 4 times y minus 8 equals, and then that was going to be 7 plus 5 is 12, and then we get 22. Okay, and now I want to, this again is linked, so I can actually divide, since this is being multiplied, I can actually divide by 4 because these will cancel out. So if I divide by 4, I get y minus 8 equals, and that's actually going to be 11 over 2. Okay? So again, you have to kind of, again, your mind is going to start helping you think of what is like linked together and what's not and when you can do what. And again, it just takes a lot of practice. So now I'm going to add 8 to both sides, and I know that 8 over 1 is the same as 16 over 2. So 16 over 2 plus 11 over 2 will give me 27 over 2. So y equals 27 over 2, which is the same thing as what we got before. So again, reverse order of operation for these, but then once you start getting fraction bars and parentheses, it can get a little bit more complicated, so you just have to be very, very careful.